So, okay, students, let's work through this bell ringer and see if we can help you learn multiplication, but also the extension of what we call a polynomial identity. A polynomial identity is basically a relationship. It's a relation that is always true, and this one you're going to find out is what we call the sum of two cubes. So let's work through this and see what we get. Remember, we use the distributive property. We take the x and we multiply by x squared. That gives us x cubed. We take the x and we multiply it by the negative 2x, and we get minus 2x squared. We then take the x and we distribute it to the 4, and that gives us a positive 4x. And we start with our second term in the binomial. 2 times x squared gives us plus 2x squared. Okay. And then we take the 2 and we multiply it by the negative 2x, and then we obtain negative 4x. And then we take the 2 and we multiply it by the 8, and that gives us plus 8. Now we combine our like terms, put them next to each other. So let's say x cubed minus 2x squared. Like terms here, so let's put this 2x squared here. And then let's put the 4x. And then let's put the minus 4x. And then let's put the plus 8. Now what you can see is these terms go away. These terms go away. And I'm left with x cubed plus 8. Now, this identity is actually called sum of two cubes. And this is what we call a polynomial identity. And what I mean by polynomial identity is basically it sets up the relationship. If I let the x be a, and I let the 2 be b, this becomes a squared minus a times b plus b squared. And that is always equal to a squared plus b squared. So when you see a polynomial identity, you have to see, does it make sense? There's a couple of those. We're going to go over about 8 or so of them, but a couple of those are just identities. And I'm sorry, I wrote the wrong work here. Let me erase. A cubed. B cubed. Okay, so that's a sum of two cubes. Basically, this is a all cubed plus b all cubed. So whatever a and b is, it is always factorable in that form. So you'll have to start applying that. So a in this case was x and b was 2, but you could have made a to be 2x and b to be 3, and then wherever you see a and b, you just replace it with that value, and that becomes the same thing. That becomes the same area. Okay?